Hello, welcome to Software Development Practices. My name is Greg Walker and I'm with 18F. This was created for the Office of Child Care at the Department of Health and Human Services as part of the Software Development, Procurement, and Management Fundamentals course. This presentation is part 4 of that course. It's a 5-part series and it covers Agile Management, Product Ownership, User-Centered Design, Software Development Practices, and Agile Contracting. 18F is a technology and design consultancy for the US government inside the government. We're federal employees who teach partners how they can improve the user experience of government services by helping them build and buy technology. We're all federal employees, so we share the same motivations as you, delivering great service to the public. A little bit about me. I have 15 years of experience in the federal government. Prior to 18F, I worked at the U.S. Army Corps of Engineers in a research and development center, mostly doing civil works related to disaster response and recovery. Most notably, about 2 months out of college, I was put in charge of the geospatial data system for all of the data collected after Hurricane Katrina. I don't know why they thought it was a good idea to put somebody straight out of college on that, but they did. It worked out okay. I got a medal. Everything was cool. And I learned a lot. Since coming to 18F, most of my work has been related to public benefits. Actually, my very first project was with the Administrations of Children and Families and the Office of Refugee Resettlement. From there, we worked with states on child welfare modernization. This was mostly just talking about kind of the same things we're going to be talking about here, is how to set yourselves up for a successful acquisition to get the product that you need. I also worked on state Medicaid projects, similar kind of thing. And that actually led us to working with our federal partners on Medicaid on IT policy and oversight, how to help the feds kind of get out of the way of the states doing the work that they needed to do. And I'm joined today by my colleague, Randy Hart, who will introduce himself.
Hi, I'm Randy Hart. I am a acquisitions lead with 18F. I'll be sharing in the 5th module about Agile Contracting. Similar to Greg, I started with the federal government in 2002. Similar to Greg, they threw a huge project, a huge contract at me right out of college. My experience wasn't as great as Greg's, but I did learn a lot, and I'm happy to be here.
I highly recommend you check out part 5 in this series when Randy will go into more detail about his experiences and what he's learned from that. All right, so let's just go ahead and dive in. We're mostly going to be talking about a specific set of software development practices and philosophies. You've probably heard of it. It's called DevSecOps, or sometimes shortened to just DevOps, because that set of philosophies pretty well encompasses what most high-functioning, productive, and healthy teams are doing today. DevOps is about breaking down silos and enabling continuous iterative delivery. DevOps combines software development, security, and operations into one team, and it automates as many of their processes as possible. This lets people focus on the hard problems and lets computers do the repetitive stuff. In the Agile Management presentation, Lindsay talks about cross-functional teams, and DevOps is an enabler for that. When you automate a bunch of stuff, you really free up your team members to work on the hard problems more closely. As she said, you use the whole team's brain. The whole team working together is always going to do better work than everybody kind of working alone and trying to put all the pieces together at the end. And when it comes to automation, computers are really good at doing the same thing over and over. Why would we not let them do that? People aren't great at it. We get bored, we get distracted, we forget a step. Maybe there's a child that's home from school one day and you just like forget a step. It's really easy to do. Like anything can go wrong. Computers don't have those kind of distractions. So if we can let them do something over and over, sure, let's do it. The slide does say DevSecOps enables continuous iterative delivery. So let's take a look at what that means. Before we talk about that, though, we should probably start with what does a classic or manual deployment look like. And these processes begin with a change, or more realistically, a bunch of changes. I think what we usually see is that several months worth of work, or maybe even years worth of work, all gets bundled up into one change. Once that happens, it kind of gets thrown over a wall to an entirely separate group of people that do testing. This is a lot of times this is staff who kind of walk through the product, and maybe they're looking at a test plan, or maybe they're reading change notes, trying to figure out what it is they need to test. And then they're trying things out and making notes about what doesn't work. This can also include IT staff. They may run security scans or do compliance checks. And depending on just how big those changes are, this step where you do testing and your compliance and security scans, this can take a long time. The last time I worked on a real waterfall project, we literally set aside 3 months of the year just for this process. So we would do 9 months of development and then throw it over the wall and just wait. Now, assuming you get through all of that and all the tests, are successful and everybody's happy with everything, then you kind of throw the whole thing over another wall. And this goes to another set of technical staff who go about deploying the product. And the way that you deploy a product is basically typing a whole bunch of commands into your computer in just the right order. Don't make any typos, because if you do, you could break things. If you mess up, you can bring your whole system down for a while. Or you could do something like I've done before and actually delete a whole database, which is horrifying when it happens. But it's easy to do. So this process is actually really hair-raising and scary. And
an example of this, just that I think about, is the healthcare.gov situation back in the early 2010s. For folks that are familiar with that, it was a pretty big deal. It was a major legislative event where they had to go live with healthcare.gov, so everyone that could use insurance would use this website to shop for and get their insurance through the website. And it was the same sort of traditional delivery process, where unfortunately at the very end, when it did come time to deploy, the system broke, and they spent months doing really hard, important work, but at the very end they were left with really a disastrous result. And what we're talking about today is what the lessons they've learned, because they have improved healthcare.gov since then, but what lessons we can also learn about approaching software differently, so that there isn't all that risk bundled at the very end like they experienced.
Yeah, thanks for that. We'll actually talk about healthcare.gov some more in this talk. And the reason that we kind of talk about healthcare.gov occasionally is really twofold. One, they had a very public kind of failure, but more importantly, they fixed it, right? Like they went in, they fixed the product, they adopted these good practices that we're talking about, and now they haven't really had those kind of issues again since then. So we kind of look at them as like a case study in how to fix these kind of failed systems. But anyway, traditionally, this is how it's all done, right? There are these walls, there are these very different teams. These teams don't really interact very much. There's no collaboration happening across these boundaries. And these big delays kind of get baked into your entire process. So nothing really happens quickly. So what happens with continuous delivery? Well, it also begins with a change. The difference here is that a change is actually a really small thing. We really mean every change. So this could be something as simple as one of your developers makes a change to the code, or maybe a program staff member updates some text because they realize that it's easier for users to understand it. It could be something as silly as like, oh, we've decided to update our agency logo and we want to put that new logo on the website. That's a change. And we want to be able to test those changes as soon as they happen. In order to be able to test them, we have to be able to deliver. And that triggers this delivery process. So once the change happens, we kick off a series of automated tests. And there's a lot of different things you might test at this point. So for example, you might test functional logic of your product to ensure that your business logic isn't, that your business logic is still being executed properly, sorry. Or if it's not, if something's gone wrong in the business logic, you know that so that you don't send it out to users. You can also do some accessibility testing, so you can make sure that all of your users can actually use the product that you're putting out there. One quick note about accessibility testing. You can only do about 40% of accessibility testing with automated tools, so you're still going to have to do some of it manually. That said, this is 40% you just don't have to do. You can do things like test the quality of the code that your developers are putting out. And that's really valuable because it makes sure you get this really good maintainable code that you can use for a long time, and you'll be able to keep it updated as your needs change. This also makes it easier, like if your vendor team needs to swap out somebody, need to bring in a new developer, it makes it easier for them to come on board. Or if you have to need, if you have to change vendors, that makes that easier as well because the code is consistent, good code base. And another thing you can do is security scanning, which is pretty awesome. Security scanning is huge because it contains a bunch of subcategories. So you can have things like, you may hear things like static test or dynamic test or package management and more. But the important thing with security testing here is that it's baked into your process from the beginning. And that's going to make your life a lot easier down the road rather than trying to like bolt on security at the end or, bring in your security staff and ask them if things are good after your product is huge. You can actually do these checks all the way through from the time it's very small until the very end. That leads me actually to another point, that automated testing can be a catalyst for unsiloing your teams. And specifically, I want to talk about how that works in the context of security, because you may remember, if you've seen Lindsay's talk, she mentions that you should include your security team right from the beginning. If you do that, you can understand kind of what your security testing requirements are, what are your compliance needs down the road, and you can work together to figure out how to do those tests in an automated way that satisfies their concerns in a repeatable way so that your product is more likely to be secure, less likely to have security incidents, and more likely to comply with all of your requirements at every step instead of trying to figure it all out at the end. These automated tests are also really useful for empowering a product owner because they provide you this really quick kind of pass-fail view of the various parts of your product at any given time. Being able to glance at the results of your tests can give you information that helps you have constructive conversations with your team. And it'll help make sure you're delivering the quality you want as well. As a product owner, it's not really your job to interpret those test results, so it's fine if you see a test is failing and you don't really understand exactly what that means. But being able to see that the issue exists lets you know who to go talk to. And it lets you have confidence that the thing you're delivering is working the way you intended it to.
An important part of this is, especially if you have a contractor team that's doing the work, is having that insight as a product owner, as a government buyer, into what the team's doing. So you don't have to be the expert in all these things, like Greg said. But as long as you know what quality measures are and what it is that you're looking to be reported on, having that knowledge gives you a sense of confidence that the team is doing the work. And if there are issues, it's transparent in the way that they're doing their continuous delivery, so that you always know at least what's going on. We're trying to get out of that black box situation that we find ourselves in too often.
Yeah, absolutely. Especially because this is happening with every single change, right? Like this could be happening potentially several times a day, and you could just have like this constant insight into where things are instead of, every quarter you get a delivery or every year, or in the worst case we've seen, I think sometimes several years until you get a delivery. So this is nice to be able to just have that kind of pulse check. So once all those tests are done, it's time for delivery. So this delivery is similar to the deployment step I talked about earlier. There is one thing I want to cover real fast that's not completely automated, which is that you can have manual review steps. You don't have to have everything be 100% automated. In fact, some things have to be done manually. For example, if you have changed some text on your website, you need a human being that can check that and make sure that it's that it's plain language and make sure that it's actually conveying the right information. Or remember, accessibility testing, you can only do 40% of it with automation. So some of it has to be done manually. You can also have someone that reviews the code. Just make sure it's logical. The code may have passed the quality checks. It may be consistent. It may use good practices. That doesn't necessarily mean it's the best code, because you can make these logical inferences that may or may not be accurate or may not be the best. So just having somebody to kind of look at that is helpful. Adding that manual step might sound like it introduces delays that we are trying to eliminate with automation. But because this process is happening for every change, the reviews are actually usually very small. So if you're reviewing someone's new, they've changed some text, it's probably just a few sentences rather than several pages of content. Or say you've just added one new button and you're going to do the accessibility testing manually. You really only have to test the accessibility of that button because all the rest of the things haven't changed and they've already been tested. You don't have to test them again. Having these smaller, more frequent changes means it's a lot easier to check everything. And it also means that manual reviews should be pretty quick. So once all the tests and manual reviews are finished, everything's passed, now we can actually get on with the delivery. And delivery here can mean several things. It can mean, most commonly, I think for our context, it's usually like we've updated a website or we've made some changes to our API, or maybe we've even updated a database to change the structure of the data to be more useful for us. If you're building a mobile app, something like that, which 18F doesn't recommend, but sometimes that's what you need to do. This delivery could mean pushing up to an app store and getting the latest version published there. This delivery process is also automated. So just like the tests, once you've figured it out and you've got it working, it just keeps working. The computer just does it. One last thing to mention, these automated deployments can go to different places. So you're probably familiar with production or staging, development, those kinds of things. In the DevOps world, we call those deployment environments. And you can kind of conditionally deliver to any number of them. For example, maybe every single change that comes into the system ends up getting delivered to the development environment. And that way your development team is always working with the very most recent, latest things. But you maybe don't want to deliver those changes to your users every time. Maybe you have a separate group of users for user testing and they get, maybe you push them when a major feature is complete. And then you push things out to the public, maybe at the end of a sprint or whatever. But the important thing is you don't have to deliver every change directly to your end users because DevOps does embrace this idea of multiple environments and only delivering to them when that is appropriate. So how does this actually help you? Well, continuous delivery is making the latest changes available as often as possible. Continuous delivery is about frequently delivering small pieces of your product, and that enables continuous user research and feedback to steer the product direction. Continuous delivery is really the engine that powers this kind of quick and iterative development. If you're not able to get your changes out in front of your users, you can't test those changes to make sure that you're actually meeting the user's needs, or find out how you're coming up short if the feature maybe isn't quite there yet. Delivering small changes frequently is what enables you to know you're on the right track and help you figure out and refine what exactly it is that you're trying to solve. Continuous integration is testing everything constantly to catch problems early. Continuous integration should increase your confidence that the product is working as expected and not regressing unexpectedly. The regular integrated security scans reduce your risk of security incident and may reduce your compliance burden down the road. Continuous integration is really about making sure that you're delivering what you expect, make sure the product does what you expect it to do. So this is really about satisfying your needs as a business more than the user's needs. This is a chance to enshrine your business requirements into your process and reducing the risk of things going off the rails. Testing code quality reduces your long-term maintenance costs, and it prevents this problem where one person has all the knowledge of how it works in their head, so you can't replace them. If your vendor, like I said, if they need to bring in someone else or you need to swap vendors, it makes that easier.
And going back to the healthcare.gov, we remember hearing the story about there was somebody that pushed something in one of their environments. It was a pretty minor change from what I understand. It was a minor change to the software, but it had some problem way down the line in some other environment that they couldn't figure out because they hadn't built that continuous integration from the beginning. And so they didn't find it until the end when they were trying to integrate all the systems. And that led to weeks and weeks of challenges. And this is what this is trying to get away from. It is get into doing that continuously so you're not having that risk at the end of an integration break.
Yep, absolutely. It is absolutely about pulling the whole thing together and testing it all at once, because it is actually very common, especially for big systems, to have multiple teams working in parallel. That's very common. We don't recommend starting that way. I think Lindsay talks about it in the Agile management presentation, that we recommend starting small and kind of getting your bearings and learning how to do this work. But it is very common to spread or to work in multiple teams simultaneously. And it's important as well that if you do that, you actually pull all their work together for this kind of continuous integration. Because otherwise you run the risk of exactly what Randy's talking about that happened to healthcare.gov. Lindsay also talked about some of the good signs that your Agile processes are going well. And one that she mentions is being able to catch problems early. Continuous integration is a huge part of being able to do that, right? Because it's happening with every single change. So when there's a problem, you should find out about it probably within minutes, which is super helpful rather than, months later, like with some of the other examples we've talked about. And automation is doing the same thing the same way every time. Automation reduces the risk of a mistake, bringing your whole system down by ensuring the delivery process is consistent. Automation reduces the risk of those frequently run processes going astray because someone made a mistake. Like we said, people aren't really that great at doing the same thing over and over. We forget, we get tired, maybe you didn't sleep real well last night, maybe you had a headache. And for things like deployment, there are so many things that can go wrong. So we automate it, right? Like just figure it out once, and then we roll with it. Let the computer do it over and over. Automation also tends to speed things up. So if you think about a more traditional approach, where you take a bunch of changes and you hand it off to like a QA team that does user acceptance testing. In our experience, the people that do that user acceptance testing, that's kind of like an other duties as assigned role for them. They tend to have like a real job. And so they're just kind of trying to cram that QA work into their regular schedule. So it may take a while. They may be busy with other things, and it may take a while before they're able to pick up that work and do it. So how long is it going to take? Well, it just depends on how busy they are. Same thing with the IT staff that do the security scans. They're probably supporting a lot of projects, and it's going to depend on just when they can get to you. With automations, you don't really have to worry about that because the computer's just kind of sitting around waiting to do stuff anyway. So it can pick it up, pretty much right away. Without automations, we can't really do continuous user research and feedback because there are these long delays that we just can't really do anything about. Automation helps us get rid of those. So how do you do it? I'm going to go ahead and spoil this by saying we're not going to get deep in the weeds on how you actually do DevOps because there are two keys that we think are super important. And the first is that someone on your team needs to be fluent in software development practices. All the automation in the world is meaningless if you don't understand the outputs. To review code, to interpret tests, to provide feedback on technical direction, you need someone in a tech lead sort of role. Without them, you won't know when you're off course or how to correct it. In the Agile, oh, go ahead, Randy.
I just also wanted to add, there isn't a magic tool you can buy to replace that person. Like their automation is a lot of tools that I'll never understand, but it is an important thing to have automation. But there's nothing that you can buy out of the box that says, I'm going to take the role of that technical lead that Greg's talking about. It really is important to have that person on your team helping to interpret the way that Greg's talking about.
Yeah, and Randy, in your presentation on Agile contracting, you talk about the quality assurance surveillance plan, right? And that's a great tool, but it's not very useful if you don't have someone who can evaluate your product against the metrics that are described there. That's one of the ways that a tech lead is going to help you. They can also do things like reviewing the code and make sure it's solving the right problem in the right ways. They can look at tests. And this is actually really important because it is technically very easy to write tests that don't do anything but look like they do something. And a tech lead can see that, and they can let you know that that's happening. Not to dump on healthcare.gov too much, but they had a problem with this as well. They had a contract that said the tests must run every single day. So the vendor, but the vendor wrote the tests and they ran them, and it turns out that running the tests would actually crash the system if they were allowed to run to completion. So the vendor, in order to satisfy the contract, would start the tests every day and immediately stop them. And that satisfied the contract and it prevented crashing the system, but it didn't actually give anybody any confidence about anything. We don't want that. And so a tech lead can kind of help you avoid those kind of situations. Perhaps most importantly, having a good tech lead will help you see when things are going off course technically. And they can do it sooner than you might do it otherwise. They'll also be able to help you steer the product back on track. And so in this way, a tech lead is a huge risk reduction. I do want to acknowledge, though, that we're making a huge request, right? Like hiring is hard. Hiring is so hard. We have a hard time hiring. We've seen and heard it from our federal partners, our state partners, how hard it is. You know, government is resource constrained. It's hard to attract talent. And it's also just, you know, the policy thing about how many people can you hire and for what roles. We get it. But that said, we have absolutely seen this role be the difference between success and failure. Your tech lead role can be a state employee. That's kind of the ideal situation. But we have absolutely seen people be successful with contractors in that role. The only note I would make is if they are a contractor, they need to be separate from the contractor that's actually building the product. That's just to avoid conflict of interest.
And one more thing just about the tech leads, the ones that I've had the most success or best relationships with are the ones that help me not have to know all the technical things. They can translate the technical things in a way that I understand. Ideally, the vendor that's doing the actual work will also want to speak to people that are non-technical. Oh, you got it right here, Greg. But that idea, that's been just a game changer for me in working in these new ways of having that tech lead that really helps to not make this some magic box thing that only they will understand, but really helps me understand what I need to understand.
Yeah, absolutely, because it's not a magic box, and it's great to not treat it that way. You know, what makes a good tech lead? It's somebody that understands kind of all the components that we talk about in this entire series. You know, software development, product management, user experience, agile methodologies, and user-centered design. They're not necessarily experts at any of it, but they should be able to look at it and say, that is right, or that is wrong. You know, this is a good practice, that's a bad practice. Your tech lead's not doing all of this work. They're not a designer, they're not managing your product. They're more of an oversight and advisor role, kind of like Randy talked about, right? Like they decipher techno babble into like normal people talk. In the product management presentation, Shield talks about product ownership and how it sits at the intersection of user needs and stakeholder management, technology, and business. The tech lead is the person who can help the product manager or product owner understand what's technically possible and be their advisor on technical strategy and direction so that they can make the best decisions they can. One analogy I like to use for the tech lead is like the foreperson at a construction site. You know, if somebody's building your house and there's this foreperson, they're not laying tile, you know, they're not running pipes, they're not, you know, putting in your electrical wire. They're overseeing the people who do that, and they can report back to you and let you know kind of what they're seeing, you know, what it is that you want, how those two mesh together. You know, they know enough about plumbing and electrical work that they can go to the plumber and say, hey, you did this wrong. You need to do this differently. And they help you as the client fundamentally understand what is possible. And they have like this big picture view in their minds of what it is you're trying to accomplish. And their job is to kind of connect that big picture view with the understanding of the specific subject matter experts that are doing the work and make sure that everybody's delivering properly. So really, like Randy said, their job is mostly about communication. They're just trying to reduce the expertise imbalance that we see so often in government vendor relations, where the vendor has all the technical expertise and the government side has very little.
And the best, if you are in a situation where you have either a vendor or an in-house tech lead and you have a vendor team that's doing the work, the best situation is where they are almost collaborative with an arm's length kind of approach, but collaborative where they're not just waiting till the end and then saying, oh, they're doing it wrong, but more figuring out with the vendors, how they're doing the work, trying to understand why their decisions are what they are. A lot of times we'll ask the vendors to document if they make some architectural decisions as they learn more. We'll ask them to document it. The tech lead on the government side will be able to kind of understand that work. But that is why it's important to have those separate, because even the best vendors, it's not in their interest to have too much of that going against them or have too much, problems that arise that you can't just assume that they're going to fix it on their own. Hopefully they will, but if not, it never hurts, and it always helps to have that expertise in house.
Yeah, absolutely. The next major key is to build your DevSecOps pipeline at the start and insist that your team use it. The sooner you have a pipeline, the sooner you can have these small, frequent deployments, and that makes it easier to make changes, and it helps the project move ahead smoothly. In healthy software deployment or development projects, that DevOps pipeline is often the very first thing that gets built. Doing it early is easier. Retrofitting it into an existing problem or to an existing project can be a challenge. I guess some projects are problems. But doing it early also lets you benefit right from the beginning, and you kind of have a compounding effect. I know this isn't helpful advice if you're already in the middle of a project. You can absolutely add DevOps to an existing project. It's just harder, and it's good to go into that knowing that it's more difficult. If you're in that situation, I would say start small. Maybe your DevOps pipeline begins with just automated tests, and maybe you only put in automated tests for new functionality, rather than trying to spend a lot of time going back and adding tests to existing functionality. Over time, you can add in tests for the pre-existing functionality, but just to get started and understand, how this process works, I would say start something small like that.
And just to reiterate, we see a lot of times where folks do see the benefits or see what they could get out of having a DevOps pipeline, and it's not as easy as just going and buying a tool and saying, now use this tool, this will make it DevOps. That cultural communication change is what's really important. So if you're already in a situation where you don't have that pipeline, where you don't have continuous integration, continuous delivery, it's not something. Sometimes we see a lot of vendors that are proposing these solutions to make you DevOps. Be wary of that, because it's not as easy as just putting a tool in. If it's not built from the beginning, it does take a lot of effort. It's doable, like Greg said, but be wary of any shiny objects that might be pitched your way as being your way of modernizing into DevOps.
Yeah, that's a really good point, because it's not about the tools, right? It's about being able to do this work more rapidly. It's about being able to get things in front of your users quickly. It's about being able to kind of change your product direction based on what you're learning as you go along. Shield talks about, getting to the grocery store to buy groceries, and there's the Homer Simpson car version, or there's the skateboard bicycle car version. DevOps is about making sure you do the skateboard bicycle car. So if a vendor is like, oh, we have this one-off solution, but the actual result is you just keep iterating on a car, there's no point. That's probably just money down the drain. So if you're looking to build a DevOps pipeline, or if you're talking to a vendor about it, here's some of the major common components that you should be looking for. These should always show up. The first one is version control. Lindsay talks a little bit about version control in her presentation. And it's basically a system for keeping track of changes to your product over time. You've probably done some version control working on a document. Maybe you're writing a report and it's named report.doc. And then you have report underscore final dot dot, and then report underscore final underscore one dot doc, and so on and so on. And that is a form of version control. It's not a super friendly one, but it does serve the same purpose. For software projects and for source code, we use version control tools that track all of our changes without having to have multiple copies of a file. So it just keeps track of, the change of a file over time. There are several of them. The most common one that you'll hear of these days is called Git. So if you've heard of a tool called GitHub, it's using Git under the hood for version control. And these tools let us see what changes happened, when, and who made them. They also let us go back in time if we need to change something. We've created a new feature and it turns out users hate it. We can just rewind the clock. It takes a few seconds to do. The most important property for DevOps purposes is that these version control systems create events when changes happen, and we can use those events to kind of kick off our DevOps pipeline. The next thing that you should be looking for is continuous integration, and we've already talked about that one in a lot of depth. That's where your automated tests, your security scans, your manual reviews, that's where that happens. The next one is infrastructure defined as code, and that's not always present, but you should definitely push for it, especially if you're working in a cloud environment. Today, we mostly work with virtual computers, right? So when we say we're going to deploy our website, we're going to push it up to the web server, there's probably not a physical server that we're referring to. It's probably a virtual server. And virtual servers are created by software, which means that we can define their specifications in such a way that we then feed it to the software and the software can create it for us. So you can write the specifications for your virtual computer, you can put it in a file, and now every time I need to create a server, I just say, here's my specs, do it. And that's infrastructure as code right there. It's just writing basically your system specifications. When I say system here, I should be clear that I mean like the computer itself, not your product specifications. This lets you quickly and easily create whole new environments too, right? So you've got product, you've got development. Maybe you want to create a new environment just for one feature. It's a really big feature. You want to spend a lot of time iterating on it with users. You can do that because you've got your specifications in a file. You can very quickly create a new environment, and it's repeatable and it's auditable. So once you've got an environment that's compliant, you can create more environments that are also compliant. And the last one is testing and monitoring. And these let you know that the changes you're making aren't breaking your product. Or if they would break your product, they let you know that. DevOps practices should help increase your uptime because tests are catching problems before they get to users. And monitoring is watching your product while it's running to make sure that it's still working. So if anything goes wrong, good DevOps practices are going to help you see it sooner than you would have otherwise. And the key takeaway that I would love to leave you with from this talk is that DevOps enables continuous iterative development. It does not create continuous improvement, but it creates an environment where that's easier and more possible. So like Randy said, the real key to DevOps is kind of the culture change of really collaboration, breaking down the walls and talking to each other more. Without the constant tests, it's harder to be sure you're not breaking your product. Without constant deploys, it's harder to get good user testing and feedback. And without the automation, you're spending a lot of time doing things that are not building your product, which is just slowing your product down. Ultimately, DevOps is just a tool. It's here to help enable everything else we've talked about. Agile practices, product management, user-centered design. And it's also an enabler for Agile contracting, which Randy talks about in the Agile contracting presentation.
One other thing, and this might be clear in what we've talked about, but getting other parts of the organization, those stovepipes that Greg talked about, getting them involved early in the conversation and having them understand the approach that you'd like to take and having them work with you to enable those approaches, that's critical, because we have seen sometimes where worst case is you've got really great stuff that's being built by your vendor. It's ready to go into production. They've put it in front of users. They've tested it out. It's good to go, but then it hits a roadblock when it comes to either deploying because of security, documentation concerns, or somebody in IT says we need to deploy it in this way, having those conversations earlier helps enable success, and it helps enable DevOps. The best way to do that is to start going on something. One thing that Greg and I have seen quite often is, because there's so many potential pitfalls that could come from different parts, different stovepipes getting in the way, it kind of stagnates, or it makes it so that you're kind of paralyzed by the idea of moving forward in any way without having everybody on board. One thing that we do push is, like, see if you can start on something small, prototype even, maybe not something that's going to go into production, but see what it's like to try to go through a whole pipeline, so you can expose those blockers earlier in the process versus waiting till the end and then having all those blockers come. That's just the one thing, and it takes a lot of effort on the team's part to figure out who it is they're supposed to be communicating with, but getting those folks on board from the beginning is really important.
Yeah, and doing something like that too lowers the stakes, right? It's easier for people to say yes to something very small. It's also just easier, like if they do have to actually review the thing that you're creating, that's easier too because it's small. And like Randy said, getting the names of the actual people that have to be involved in making decisions, as opposed to, Lindsay refers to getting rid of change control boards. I wholeheartedly agree, because saying that we need to go through the CCB is very different than we need to get Bob to sign this. And talking directly to Bob is going to be a lot faster than waiting on the whole board. Well, I hope you found this useful. We're planning some Q&A sessions later on, and I'd be happy to answer any questions you may have in those sessions. Thank you very much.